Hello everyone, I hope you're doing well. So in this video, we're going to discuss the first 4 problems of Codeforces Round 884, which was rated for both Division 1 plus Division 2. So today's contest was pretty average for me. I made a lot of mistakes, some mistakes in implementation and some mistakes in the correct logic. Though the first 4 problems were not very difficult, due to my mistakes, my rank was not very good. And regarding the fifth problem, I believe that the difficulty difference in the D and the E problems is pretty huge, as you can see by the number of submissions. And there were many high rated people in my friends list who have not yet completed E problem, and there are only 50 minutes left. So I believe I would not be able to solve this particular problem, and hence I decided to record the video. So for the first 4 problems, they were pretty straightforward and easy, and let us discuss them one by one. Now starting off with the first problem, this problem says that we have been given two integers a and b, and there are two players playing a certain game. Now the first player at each turn can only pick a number of stones, and the second player can pick b number of stones, right? So this is the fixed amount that they can pick, and any player who cannot pick any stone loses, right? So this is our whole question. Now we have to find the value of n such that the second player always wins no matter what happens. Right, so this is our whole question. Now how we can solve this problem? Let us see. So if there are two values a and b, right, the player 1 can only pick a number of stones. So what I did was I print a plus b. What happens in this case is the first player is going to pick a stones and the second player is going to pick b stones, right, and then 0 stones will be remaining. So the first player will not be able to pick any stones, so the second player will always win. And since at the end the number of stones will be equal to 0, player A will not be able to choose any stones. So this is a very simple problem. You just had to add both of those numbers and you could have got one possible solution. Now I believe there might exist other solutions as well, but this was one of them and you just have to add both of the numbers. So let us have a look at the second problem. So this problem is permutation and primes. So for this particular problem, I made a wrong summation on p-test 2. So there was some error in my logic, but overall the problem says that we have been given an integer n and we have to construct a permutation of size n, and we have to construct a permutation such that the number of pairs ln r, right, if you take them, their mex should be a prime, right. So if you take a permutation and count the number of pairs ln r such that their mex is prime, their mex means all the elements between the range ln r, if their mex is prime, that means we'll have to add 1 to our answer for that particular pair, right. So for all these pairs we can count them and that will be the primality of the array. So among all the permutations we have to print a permutation with the maximum primality. Let me just discuss this sample test case and show you what this question is saying. So if we have it here, so for this test case the answer is 5, 2, 1, 4, 3. Right. So again this is only one of the possible answers and there might exist several different answers. So first of all let us discuss what is MEX. MEX, if you don't know, it is minimum excluded, and what MEX generally means is if you have for example some elements 1, 2, right, so their MEX is 3 because 3 is the minimum element that is not present in this particular range. And if we write let's say 3, 5, the MEX will be 1 because 1 is the smallest element not present in this range. Let us discuss one more example, 1, 2 and 5. So the MEX in this case will be 3 because 3 is the smallest element not present in this particular range. So with this definition of MEX, let us try to find the number of pairs in this case, and we already know that it is going to be 8, which is the maximum for any permutation of size 5. Let us see how we can find the answer 8. So the first range is this one, right. So their MEX is 3, it is a prime number, so the first range is this one. Then we have this particular range, again the MEX is 3, again it is a prime number, and then after that I'll have to take this particular range, MEX is 3, so till now I have found 3 ranges. Again this particular range has MEX 3, I have found 4 ranges. For this particular range the MEX is going to be 5, I have found 5 ranges till now. Now this single element will have MEX 2, I have found 6 ranges, and if I take these two elements the MEX is going to be 2, I found 7 ranges till now. Again if I take this range the MEX is going to be 2 and I found a total of 8 ranges. So this is how you can see how I can form different pairs of LNR such that if I take all the elements between L and R, then MEX is a prime number, and there are 8 such ranges in this particular case. So generally in these cases, either there is some pattern or you might try to restrict your answer, right? So we want that the MEX should be prime, right? So for larger values of n, the prime number can be anything, right? So in this particular case, it would have been much beneficial if you would have tried to restrict your prime number. In this case, I'll try to restrict it to 2 and 3, right? So how can I do this? If I put 2 in one corner and 3 in another corner, and if I put 1 in between, and let's say we have some elements here and we have some elements here. Now what will happen is, let's say I have some elements x, y, z, right? And there might be some elements p, q, r here also, right? So now what happens is, if I take this particular one and I take some number of elements from the left side or some number of elements from the right side, as long as I am not including this particular 2, my MEX is always going to be 2, which is a prime number. If I include this 2 but I don't include this 3, my MEX is going to be 3, which is also a prime number, right? So let us see how many such like ranges of LNR are possible, right? So we have some elements here like this. So if I don't want to include this 2, the smallest thing I can form is this one. Then I can take, let's say there are 1, 2, 3 elements here, and there are 1, 2, 3, and let me count this one also, 4 elements here, right? So I can take any number of 3 elements from the left side and any number of 4 elements from the right side, and their overall MEX will be 2 only. So let's say I take 2 elements from here and I take 2 elements from here. So this will be the range. In this case, the total number of values will be 4 into 3. Similarly, if I try to form the MEX is equals to 3. So let's say there is 1, 2, 3 and 4 values here, and there is 1 and 2 values here. So I can take maximum 4 values from this side and maximum 2 values from this side, and the total number of ways I can take the values, or I can set the range of LNR is, in this case, 4 into 2, right? So why am I showing you this? Why am I showing you this particular multiplication part? You will see my number of ranges will increase if I try to make these two elements equal, right? Let's say the total number of elements are 7, right? So if I have one element on the left side and 6 elements on the right side, product is 6. If I have 2 elements from the left side and 5 elements from the right side, the product is 10. If I have 3 elements on the left side and 4 elements on the right side, the product is 12. So if the summation is going to be the same, which is in this particular case, the total number of elements will be the same, right? But if I try to equate the elements, equate the number of elements on either side, on this side as well as this side, my total product or the number of ways is going to be maximum. That is why I showed you this particular part. How are we actually calculating the number of ways? It is by the product of the number of elements on the left side as well as the right side, right? So I want to maximize this product. For that, I want the elements on each side to be as close as possible, right? The total sum is not going to change because the number of elements are fixed, but I can make them as close as possible so that the product is maximized, right? So the final conclusion would be to have 2 on one side, to have 3 on one side, and have 1 in the middle, and I can place the remaining elements, any elements in any order in these two sides, right? Because no matter what those elements are, if I don't take this 2, my MEX is always going to be 2. If I don't take this 3 and take this 2 at the same time, my MEX is always going to be 3, which is a prime number, right? So this is how you can solve this particular problem. Now let me just show you the code, how I did it during the contest. So you see, for n is less than 3, I have dealt it separately. If n is equals to 1, I just print 1, otherwise I print 1 and 2, and I return from here. Now for the remaining cases, I create a vector of size n and I set these 3 values. So first of all, answer of 0, that is the first position, is set as 2, the last position is set as 3, and the middle position is set as 1. Now I initialize my current value with 4. Since 1, 2 and 3 are taken, I have to take all the numbers other than 1, 2 and 3. I start this from 1 to n minus 1, right? So this means I will not be checking the first position and the last position, but somewhere in between 1 will be present, right? And I have to avoid overwriting the value. So that is why I check if answer of I is not equal to 1, then only I update this particular value, right? You can also check it as like I should not be equal to n by 2, because I already know that n1 is present at n by 2. It is your choice how you check it. It's just that you have to take care of this particular thing, that you don't override that one. And for all the other ranges, you can just insert the current, write the current element there and increment your current value so that you can write the next number. Now at the end, you can just print all the values and print a new line. So this is how you can solve the second problem. Now let us have a look at the third problem. So this particular problem was very interesting and I made some logical errors in this particular problem. That is why again I had a pretest, wrong answer on pretest 2. So the problem says that you have been given n particles and let's say you remove this particular particle, that is -1 here, right? As soon as you remove it, the element or the particle left to it and the right to it will get combined. So you see, when you remove one, 4 and 5 are getting combined and they will form a particle of size 9 or value 9, right? Now if you remove a particle from the leftmost side or the rightmost side, there is no combination that is going to happen, because for a combination to happen, both left and right should be covered by a particle. For example, in this particular case, 4 and 5 were combined, but if you remove this -3 from the leftmost corner, only 1, 9 and -9 will be remaining, right? So at the end, we have to perform the operations in such a way such that only one element is remaining at the end and we have to find the maximum value of the remaining particle, right? So let us have a look at how we can solve this particular problem. So let's say we have some particles like this. You will notice a very interesting property about these particles. So let's say this is at index 0, this is at index 1, this is at index 2, then 3, and then 4, and then 5, right? I know that I can remove this particle at index 1 and these 0 and 2 will combine. But let's see what will happen if I do this. So once I remove this particular element, these two elements get combined. So these three together is going to form the 0th index, right? So this is actually value at index 0 plus value at index 1, right? Now at index 1, the element which was earlier at position 3 will come. So let's say this is value of index 3, again 2, value of index 4, again index 3, value of index 5, right? So after the combination, so this is actually 2 because 1 is removed and that is why 0 and 2 were combined, right? So now at the position 0, V of 0 plus V of 2 is present. Position 1, V of 3 is present. Position 2, V of 4 is present. After this operation, there is one very interesting thing that you must observe, and that is, if I again try to combine this particular element, I can only combine it with this particular element, right? I cannot combine it with the next element next to it. What is the significance of these two elements together? You must notice that all of their indexes are even. This was 0, this is 2 and this is 4, right? And if I try to combine these two, let's say I remove this particular element and I combine these two, then again at index 0, V of 0 plus V of 2 plus V of 4 will be present. At index 1, V of 5 will come, and at index 2, V of 6 will come. So again you see, if I try to combine them, I can only combine this with V of 6, which is again an even index. So there is the first observation that we have here is, no matter in what order we perform the operation, after the operation we can only add the values at even indexes together. Similarly, we can only add the values at odd indexes together, right? We cannot add two values, one at odd and one at even index. That is never possible with the given constraints, right? So that means I can only add even values and odd values. So this was our first observation, that I can group odd values together. So let's say odd values are together and I can group even values together and do something with them, right? So the next idea that I had during the contest, and which was wrong obviously, let me discuss the wrong idea first so that you know what to avoid during a contest. So let's say there is something like this. We have an array like this, right? So I can combine these two values and then these two values. The overall answer can be 19, right? If I do it this way, but the best answer is 20. Let me tell you why am I thinking it to be 19 and why 20 can be the best answer. So initially I thought in this particular case, I can remove this particular element. So initially what I thought was, if I want to add all the elements at even indexes, let's say these three elements, then I will have to choose some consecutive elements. Let's say this is the first element, this is the second element, and this is the third element. I thought that we cannot remove this particular element, right? And that is why after taking all the even elements together, I was finding the maximum sum subarray, like we generally use the cadence algorithm for that. I was trying with that particular thing, and that was wrong. So you see, whenever you have this situation, you have 10 here, you have 10 here, and you have a -1 in between, right? You don't want this to be added to your answer, right? So how you can fix this particular thing? You can actually remove this particular element from between. So let's say if you remove the middle element, these two odd elements will get combined. So if you are trying to form the answer with the even elements, the odd elements are obviously of no use to you. So no matter what operation you do with them, it is anyways useless because you are now going to add them to your actual answer. So what we can do is, we can remove this particular element and these two elements will get combined, right? So 10 minus 2 will be present and then 10 will be present here. Again I can remove this particular element and combine these two elements. So you see, the next observation was, I can take a subsequence of elements. So if 10 was here, I can take the next 10. I can altogether avoid all of these negative values, and I have shown you a way how we can remove these negative values. So let's say all the even values are like this and all the odd values are like this. What I can do is, I can take all the non-zero values from here and find the total answer. In this case it is 20. I can take all the non-zero values from here. In this case it is 0 and the total answer will be 0. So I can individually find the answer for even and odd, and then when I have both of them, I can take the maximum of them. So there are two things to this particular question. The first thing is, you can only add even values together and you can only add odd values together, right? Once you know this thing, the second question was, can we actually take the elements independently or we have to take some group of elements together? So initially I thought that we had to take the group of elements together. This would be the best case, but that is not actually the best case, because you can take the elements independently and you can always remove the elements between two elements, right? As you have seen that in this particular case, I showed you how to remove this -1 between these two tens, right? So this is how you can take all the elements independently, and obviously you would only take them if their value is greater than 0. Now at the end there might be a case, this is an edge case that you have to consider. Let's say all the elements were negative. So if you don't take any of them, your answer will be equal to 0, right? So in case your answer is 0, you have to take the maximum element in the whole array, right? So if all the values are negative like this, you will have to take at least one element, right? So you can take the maximum element in the array and that will be your final answer. So let me just show you the code for this particular problem. So you see what I've done is, I've created a vector of size n and I've taken input in it, and I've taken two vectors, odd and even, and I just push back the values into these particular vectors. Now what I do is, I have this index variable, I have a value variable, and I have an answer variable. So this index is going to traverse to the odd and even vectors, and my value variable is going to store my current sum. So what I do is, while index is less than size of odd, that is, I'm just traversing to the odd array, and for all the values, whenever the element at the current index is greater than 0, I just add it to my value variable and I increment my index and I update my answer as maximum of answer comma value. I do the exact same thing for the even array. I initialize my value with 0 and index with 0. I add all the positive values and I increment my index and I update my answer value. At the end, if answer is equal to 0, that means I have not even taken a single value from both of the vectors. So that is why in that particular case, I can take the maximum value in the whole array and I can just print my answer. So this would be the solution for the third problem. Now let us move on to the fourth problem. So this particular problem represents a row major representation. So basically it is nothing, but let's say if you have a matrix and you are just writing all the elements series wise. So element 1 1 1 2, and then if there are C columns, the last element will be 1C, and then you start writing the elements of the next row, that is 2 1 2 2 2C up to 2C, and then so on. So in this particular problem, I made like a typo and I missed that I needed to take care of the indexes, and that is why I got a runtime error, and later I connected it and this completed. You see, like both the submissions are at almost the same time. So yeah, anyways, it got me a penalty. So now they say that a grid of characters is bad if there are any two adjacent cells that have the same character. So that means grid is called bad if there are any two cells having or sharing a side and having same characters, right? Now we have to construct a string of length n such that the string is not a row major order of any bad grid. That means they are trying to say that if you have been given some elements like these, let's say n elements, there are several possible grids for which this particular array of elements can be a row major order. Let me just try to give you an example and it will be much more clear with that example. So let's say we have some values 0, 1, 2, 3, 4, 5, 6, 7, right? There are 8 elements in total, right? So this is the row major order. Now you see there is not only one grid for which this can be a row major order. There are multiple grids for this will be a row major order. The first example is there is only one row and 8 columns. So this is the first example itself. Let's discuss the second example. In this case, there will be 2 rows and 4 columns. So this is the second example 0, 1, 2, 3, 4, 5, 6 and 7. The third example can be there are let's say 2 rows, there are 4 rows and 2 columns. So like this 0, 1, 2, 3, 4, 5, 6 and 7. The fourth example can be there is only one column and 8 rows. So you can fill this like this 1, 2, 3, 4, 5, 6 and 7, right? So this is how you can form different types of matrices with the same row major order configuration. So they are saying we have to construct a string such that if we try to form all the grids that are possible with that particular row major order, none of them should be a bad grid, right? And what is a bad grid? If any two cells have the same value. So let us start with the first index or the 0th index, right? So if we observe the 0th index, with what positions is it sharing a side? So in this particular case, it is sharing a side with 1. Good enough. In this particular case, it is sharing a side with 1 as well as 4. In the next case, it is sharing a side with 1 as well as 2. In the next case, it is sharing a side with only 1. So what are these values? What are these values 4? What are these values 2? And what are these values 1? So before finding those values, let us discuss how do we form these types of 4 grids. If the total number of elements are 8, then these elements must be represented as some row into some columns, right? And this product should be 8. So what will be the value of this RNC, the number of rows and columns? This value can only be an integer divisor of 8. For example, if the value of a row is 1, then the number of columns will be 8. If the value of the row is 2, the number of columns will be 4. If the number of rows is 4, the number of columns will be 2. If the number of rows is 8, the number of columns will be 1. So you see, all of these are actually the divisors of 8, right? Or the factors of 8. If the number of rows are 2, then the element adjacent to 0 will be 4. In this particular case, you are seeing that the number adjacent to 0 is 4, right? In this particular case, when the number of rows is 4, the number adjacent to 0 is 2. Here in this case, right? Again, if the number of rows is 8, the element adjacent to 0 is 1 in this particular case. So what do you observe from this? All the elements that are adjacent to 0 are actually the factors of 8 and that are actually 1, 2 and 4. Now, if I talk about the next element, what is it? The element adjacent to 1 is 5, which is nothing just 1 plus 4. For 2, it is 6, which is nothing just 2 plus 4, right? Similarly, in this case, for 0, if it was 2, for 1, it is 3, for 4, it is going to be 6. So, in this particular case, it is x plus 2. So, our final observation is for all the positions in our string, let's say we are at a position x, all the other positions that will be adjacent to this particular position x will be I. And what is I? I is going to be a factor of 8 or the value of n, right? So, I don't want x plus I for all values of I to be same. So, how we can solve this particular problem? Let's say I have an array like this. So, I initialize all of the values with 0 initially. Let's say that means all the values are same. And let us take the same example where the values were 1, 2 and 4, right? Now, I don't want position 0 and position 1 to be same. So, I can just increment this particular position. Now, I don't want 0 and position 2 to be same because 0 plus 2 is 2. So, I can just increment this position, right? Now I don't want 0 and 4 to be same, so I can just again increment this position. I have covered all the factors of 8 and I move on to the next element. Now for this particular element, I have to find 1 plus 1, 1 plus 2 and 1 plus 4. That is the element 2, 3 and 5 respectively. Since these two elements are already equal, I want to update and make it a value equal to 2. Right. So you see 0 was not possible at second position, 1 is not possible at second position. So the next element that is possible at second position is 2. Right. I have to update the value of index t. Since 1 and 3 are already different, I don't need to update it. Now for the next index, that is 5, since 1 and 0 are already different, I don't need to update it. Now let us move on to the next index, that is index 2. So I need to find 2 plus 1, that is 3, 2 plus 2, that is 4 and 2 plus 4, that is 6. So 2 and 3 should not be same, right? It is not same, so I don't do anything, right? Now 2 and 4 should not be same, it is not same, so I don't do anything. Now 2 and 6 should not be same, it is not same, so I do not do anything. And I have to keep on continuing this process for all the values or all the positions. For all the positions, let's say I am at a position x, I go through all the multiples x plus I and I make sure that they are not equal. If they are equal, I increment the value at x plus I. Right. The overall complexity of this particular problem is n into the number of factors, right, of n. So even I didn't know this, but through a quick Google search, the safe upper bound on the number of factors is cube root of n, right. So in this case, if n was 10 raised to power 6, so its cube root would have been 10 square, and this was overall 10 raised to power 8 approach. So it is not actually going to be 10 raised to power 8 because we took an upper bound on the number of factors up to n, that is 10 raised to power 6, and it is not necessary that the number of factors of 10 raised to power 6 are 100, right. So there might be a number, let's say we are just assuming that there is a number less than 10 raised to power 6 that has 100 factors, and that number x is of some order, let's say 10 raised to power 4. So this 10 raised to power 4 into 100 is actually going to be 10 raised to power 6. So you can safely assume that this approach will work. And now since you have some numbers, you want to convert it into a string. So you can assign a to 0, then b to 1 and then c to 2 and so on, right. This is how I solved this particular problem during the contest. And let me show you my final summation. So what I have done is, I have first of all taken an integer n and I have created a set s. This set s is going to store all the factors, and I have first of all pushed back 1 and n, and this is just simple factors test. I am just going from 2 to root n, and if n divides I just push this particular value I and n by I into my set, right. I am just inserting it to my set. So now what I do is I create a vector of answer. Now for all the values, what I am doing is I am traversing through all the set, all the factors, and I check whether I plus j is less than n and answer of I plus j is equals to answer of j. I increment the answer of I plus j in this particular case, and during my first summation I did not write this particular thing and I did not check whether this value is less than n, and that is why I got a runtime error. But if you include this, it will be fine. And at the end what I can do is I can convert all the values into characters. So I have to do I plus a because a is the first character, and I can just convert it into character and I can print it. So this was all about the last problem of today's discussion. I hope that you guys were able to understand the solutions. If you guys did, then consider dropping a like on this video and share your thoughts in the comments, because your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. So I see a lot of people who watch these videos have not subscribed yet. In case you're one of them, then definitely consider subscribing. It's always free of cost. You can always subscribe if you don't find the videos interesting later. So share this channel with your friends, and till the next video drops, keep coding, stay safe, bye bye.